For my second set of problems, you can see that my notation looks a little different. Instead of starting with that little f of x and going to my capital F of x notation, I'm starting with that f prime of x notation. That's telling me that this is the first derivative. So when we use this notation, we don't go back to the capital F of x notation, we just go back to little f of x notation. Now, if you notice that this function has a quotient in it, we really don't have a quotient rule for antiderivative, so I'm going to write this as a power. So I'm going to rewrite this as 3x to the negative fourth power. Whenever I can do this as a power instead of a quotient, that will make it able to find the antiderivative. Now remembering to be careful, when I add 1 onto that negative 4 now, I'm not going to get negative 5, but I'm going to get negative 3. So I'll have 3x to the negative third power divided by negative 3 plus c. Now I'll simplify that out again like I did the last time, but this time I have to tend to that negative exponent. So that negative exponent will drop underneath and become part of my denominator. The 3 divided by negative 3 becomes negative 1 over x cubed plus c. This is my general antiderivative. Notice that the notation changed here. Instead of going to capital F, I'm only going to little f of x notation. My second example looks like it has a product in it. Just like not having a quotient rule, I do not have a product rule. So I'm going to rewrite this so it's just part of 1 power. So I'm going to make this 3x squared times x to the 1/2 power. That's going to give me repeated bases and adding the exponents to make this 3x to the 5/2 power. Now from here, I'm able to go ahead and use that power rule. Add 1 and divide by that exponent.